Okay, so today we're diving into something that's, well, kind of a big deal, especially if you're dealing with systems that are, on the complicated side.
Definitely. And complex systems are pretty much the norm these days, aren't they?
Absolutely. We're talking about logical segmentation. And don't worry, it's not as intimidating as it might sound. Think of it like this. You've got a big, messy room,
Oh, I know that feeling.
right? And trying to find anything in there is a nightmare. So what do? You divide it up, you create zones for different things.
Makes sense. You're creating order out of chaos.
Exactly. And in the tech world, logical segmentation is all about doing that with complex systems. We're talking about splitting things up in a smart way to make them easier to manage, easier to secure, and way less of a headache when things go wrong
Right, because let's be honest, things do go wrong.
all the time. And that's where the security aspect really comes in. You've sent over some really in-depth notes on network and system architecture, and, well, I got to say, it's a lot to digest.
There's a lot going on under the hood, that's for sure.
So what we're going to do today is try to extract the most important pieces related to this idea of segmentation and how it all ties into building systems that are both robust and secure. We don't want to overwhelm anyone with jargon, right?
Absolutely not. The goal is to make this practical and understandable.
Exactly. So before we get into the specifics, why is segmentation so crucial in the first place? What are the big wins that we're aiming for here?
Well, two things immediately spring to mind. The first one, as we've already touched on, is security. When you divide your system into these neat logical compartments, you're essentially limiting the potential damage that can be done if something goes wrong in one area. It's like containing a fire.
Okay, so like a damage control mechanism.
Exactly. You prevent a small problem from turning into a system-wide catastrophe. And the second big win is, well, just making things easier to manage. Imagine trying to keep track of every single device and process in a huge interconnected system.
It sounds overwhelming.
It is, but with segmentation, you can break it down into manageable chunks, assign responsibility to different teams, and really streamline your operations. You can optimize each segment for its specific purpose, and in doing so, make the whole system more efficient.
Okay, so that makes a lot of sense. Segmentation equals better security and better management. Now, let's get a little more concrete. Let's talk about how this actually works in practice, starting with networks. One of the models you highlighted in your notes is the client-server model. And it seems like it's a good fit for this idea of segmentation.
It really is, and the reason for that lies in the fundamental nature of how client-server interactions work. You have these dedicated servers providing specific services, and then you have clients that request those services. It's a very clear request-response dynamic, and that naturally lends itself to creating distinct segments, because you can have a server dedicated to each segment, managing its resources, and most importantly, its security policies.
So each segment gets its own little server kingdom, basically.
You could think of it that way. And because you have that central point of control, it becomes much easier to implement things like access controls, firewalls, intrusion detection systems, all those good security measures within each segment.
And that's different from, say, a peer-to-peer model where everyone is kind of on equal footing.
Precisely. In a peer-to-peer network, you don't have that central authority, so defining and enforcing those clear boundaries between segments becomes much trickier. You could try to do segmentation in a hybrid model, which mixes client-server and peer-to-peer elements, but things can get a bit messy there. It's like, where exactly do you draw the lines?
It sounds like the hybrid approach could introduce some gray areas, maybe even weaken security in a way.
Yeah, exactly. It's not impossible, but it certainly adds complexity. And you're right, it could potentially introduce vulnerabilities if those segment boundaries aren't well defined and enforced consistently. Now, if you go to the opposite extreme, the most unsegmented model you could have is a monolithic system.
What's that, like a giant single computer running everything?
Yeah, essentially. Think of it like one massive server that handles all the processing and data storage. Everything is lumped together. Now, while that might seem simple on the surface, it's a security nightmare.
Because if one part gets compromised, the whole thing goes down.
Bingo! It's a single point of failure, and it makes the entire system incredibly vulnerable. Now, going back to networks and how we physically create these segments, let's talk about VLANs.
Ah, yes. Virtual local area networks. They sound, well, pretty virtual.
They are, in a sense, but they play a very real role in network segmentation. What a VLAN does is it allows you to take a single physical network, so all the cables and switches, and divide it into multiple isolated broadcast domains. It's like carving up a physical space into virtual rooms.
So I could have multiple VLANs running on the same physical hardware.
Exactly. And from a security perspective, this is huge. Because now, if an attacker manages to get into one VLAN, they can't easily hop over to another. It's like those virtual walls we were talking about earlier.
So it's not about physically separating things. It's about creating these logical barriers that limit the spread of, well, bad stuff.
Precisely. And this is where the how of segmentation comes in. VLANs create those logical divisions, and that's what allows you to implement security policies at a much more granular level. You can control which devices can talk to each other, what kind of traffic is allowed between segments, and so on. You mentioned reducing the attack surface earlier, and that's exactly what VLANs help you achieve.
Okay, so it's like having a security checkpoint at the entrance of each virtual room, making sure only authorized personnel can get in.
A good analogy. And because you're limiting the movement of potential attackers, you're significantly reducing the risk to your entire system. Now, your notes also mention other benefits of VLANs, like bandwidth efficiency and handling more devices. Are those just nice side effects, or are they crucial to security as well?
I mean, they sound important, but maybe not as directly related to security as, stopping attackers in their tracks.
You're spot on there. Those are definitely benefits, don't get me wrong. Being able to manage your bandwidth more efficiently, being able to connect more devices without bogging down the network, those are great things. But from a purely security-focused perspective, they're secondary.
So the primary security win with VLANs is that isolation, that containment of potential threats.
Absolutely. It's about limiting the blast radius. Everything else is a bonus. Now, thinking about how these different network models affect security, let's talk about port security. And it seems like the client-server model, with its centralized management, would have a leg up here, right?
Well, yeah, because you've got those dedicated servers managing each segment, so it makes sense that you'd have more control over how those segments are accessed.
Exactly. It makes monitoring and managing those individual network ports much, much easier. Think about it. In a typical web server setup, you've got specific ports that handle incoming traffic. With port security, you can very tightly control which devices are allowed to connect to those ports. And in a segmented client-server environment, you can do that for each segment individually. You're essentially creating a much smaller target for attackers. Now, contrast that with a peer-to-peer network where you've got all these devices scattered around, each with its own set of ports.
Trying to manage port security on all those individual devices sounds like a logistical nightmare.
It can be, especially if you're trying to enforce a consistent security policy across the entire network. And as we saw earlier with VLANs, hybrid models also introduce complexity.
So it seems like centralization keeps coming up as a recurring theme when it comes to security advantages. And that takes us to the bigger picture of architectural models. Your notes mentioned something called centralized computing as a way to minimize threat vectors. What exactly does that mean?
This is where we really zoom out and look at the overall structure of the system. In centralized computing, you're essentially putting all your eggs in one basket, so to speak. All the processing, all the data storage, everything happens in one central location, usually a very well-protected server.
So it's the opposite of a distributed system where things are spread out.
Yeah, exactly. And while that might seem counterintuitive from a resilience perspective, because if that central server goes down, everything goes down from a purely security standpoint, it can be advantageous.
Because you've got a smaller perimeter to defend.
Precisely. It's a much more manageable security challenge. Now, your notes also mention peer-to-peer networks as an example of a decentralized approach, which, as we discussed earlier, can make segmentation more complex.
Right. It's like trying to herd cats, security-wise.
Kind of, yeah. Now, let's talk about something that's become really prevalent in the last few years. CDNs, content delivery networks. My gut feeling would be that spreading content across multiple servers would make things more secure, just because it's more distributed.
Yeah, like even if one server gets taken out, the others can keep things running.
You're right about the resilience aspect, but when it comes to security, things aren't always so straightforward. It's kind of the opposite, actually. With CDNs, you're inherently increasing the number of potential targets for an attacker.
Because each server in the network becomes a potential entry point.
Exactly. So while CDNs are fantastic for performance and reliability, they can actually complicate the security picture.
It's like having more doors to lock, essentially.
A good way to think about it. And this also applies to hybrid cloud environments, where you're combining public and private cloud resources. That added complexity, that mixing of different environments, can also expand the attack surface. Now, moving on to something that's very relevant in today's cloud-centric world, let's talk about tenant isolation. and specifically the difference between single-tenant and multi-tenant cloud architectures.
This is a big one for anyone using cloud services.
It really is. Think of single-tenant as having your own private mansion. You've got the whole place to yourself, complete control over everything, and nobody else can even step foot on the property.
Sounds pretty exclusive
Mm-hmm.
and secure, I'd imagine.
It is. It's generally considered the most secure option because you're not sharing any resources with anyone else. The downside, of course, is the cost. It's like having a whole house to yourself. It's great, but you're footing the bill for the entire thing. Now, multi-tenant is more like living in an apartment building.
Okay, so you're sharing the building with other tenants.
Right. But you have your own separate apartment, your own space that's logically separated from everyone else's. It's much more cost-effective. But you're also relying on the building management to keep things secure. The walls need to be soundproof, the locks need to work, and so on.
So with single tenant, you're in control of your own security, whereas with multi-tenant, you're putting some of that trust in the provider.
Precisely. And that's a key consideration when deciding which option is right for you.
And where do hybrid and serverless architectures fit into this whole tenant isolation picture?
Hybrid, as the name suggests, is all about mixing and matching. You can have some workloads running in a single-tenant environment for maximum security and control, and other workloads in a multi-tenant environment for cost efficiency. It's about finding the right balance for your specific needs. Now, serverless is a bit different. Here, you're essentially abstracting away the infrastructure completely. The provider handles all of that, and your code just runs on demand, scaling up or down as needed.
So you're not really thinking about tenants in the traditional sense.
Not really, no. The security focus in serverless is more about ensuring that the provider has implemented strong isolation mechanisms at the function level so your code and data are protected from other users.
Okay, that makes sense. So we've gone from physical networks and VLANs to these broader architectural models. And it's clear that security is a central consideration at every level. Now, let's shift gears a bit and talk about some fundamental security principles. You mentioned the CIA triad: confidentiality, integrity, availability. Why don't we focus on integrity for a moment? How does something like checksum verification help ensure data integrity?
It's like a digital fingerprint for your data. A checksum is a unique value that's calculated based on the contents of a file or a data stream. And even the tiniest change to that data will result in a different checksum value.
So it's a way to detect if someone has tampered with the data.
Exactly. By comparing the checksum before and after transmission or storage, you can be confident that the data hasn't been altered in any way. That's how you maintain integrity. Now, your notes mention that user access controls are primarily about confidentiality, and data backup supports availability. It's all part of that CIA triad, but each element has its own specific focus.
Right. Confidentiality is about keeping things secret. Availability is about making sure things are accessible when needed. And integrity is about making sure the data itself hasn't been compromised.
That's a good summary. Now, let's talk about something that's been getting a lot of attention lately. Zero Trust Architecture, or ZTA.
It sounds pretty hardcore, like a security philosophy for the truly paranoid.
It's definitely a significant shift from traditional security models, which often rely on this idea of a trusted perimeter.
Yeah.
You know, everything inside the network is good, everything outside is bad.
Yeah, the classic castle and moat approach.
Right. But Zero Trust throws that out the window. It says, trust no one, verify everything. Every single request, every connection must be authenticated and authorized, regardless of where it's coming from.
So it's like having a security checkpoint at every single door and window, even the ones inside the castle.
Exactly. And this is especially relevant in today's world, where users are accessing resources from all over the place, from different devices on and off the network.
So what are some of the big wins with ZTA? What makes it so appealing?
Well, first and foremost, it significantly reduces the attack surface. By applying those strict authentication and authorization checks everywhere, you're making it much harder for attackers to move laterally within the system, even if they manage to breach one initial point.
So it's like limiting the damage an attacker can do, even if they manage to get in.
Exactly. It's all about containment. And another big advantage is that it provides much more granular control over access to resources. Users only get access to what they absolutely need to do their job and nothing more.
And that minimizes the risk of someone accidentally or maliciously accessing something they shouldn't.
Exactly. Now, one thing to keep in mind is that ZTA is not a specific technology. It's more of a design paradigm, a way of thinking about security. You mentioned operating systems like RTOS and control systems like SCADA and ICS.
Yeah, I was just thinking about how these all fit together.
Well, the important thing to understand is that ZTA can be applied to any of those systems. It's a set of principles that can guide the implementation of security measures. You can have a zero trust approach to securing an RTOS, for example, but it's not the RTOS itself.
So it's like a security philosophy that can be applied to any technology.
Precisely. Now, your notes mentioned components of ZTA, things like cloud security and data protection. What are those all about?
They sound like specific areas where zero trust principles are put into action.
That's exactly what they are. Cloud security, for instance, focuses on applying zero trust principles to the cloud environment. So even though you're relying on a cloud provider, you're still applying those strict access controls, those continuous verifications.
So it's like bringing the zero trust mindset to the cloud.
Precisely. And data protection is all about ensuring that your sensitive data is protected, regardless of where it resides or who's trying to access it. Encryption, data loss prevention, access controls, all those things play a role in a zero trust data protection strategy. And remember, things like better access controls and improved governance and compliance, those aren't really components of ZTA itself, but rather outcomes.
Okay, so those are the positive results of adopting that zero trust approach.
Exactly. They're the benefits that you get from implementing those principles effectively. Now, let's dive into something a bit more technical, the control and data planes.
These sound like fundamental concepts in network architecture.
They are. Think of it this way. The control plane is where the security rules are made. It's where you define things like access policies, routing rules, all the things that govern how the network operates.
It was like the command center for the network.
A good analogy. And the key thing here is that the control plane operates on a centralized basis. There's a central point where those policies are defined and enforced. Now, the data plane is where the action happens. It's where the actual data packets are transmitted, following the rules that have been established in the control plane.
So the control plane sets the rules and the data plane follows them.
That's the gist of it. The data plane is all about the actual movement of information, while the control plane is all about how that movement is governed.
Okay, that makes sense. So if the control plane is like air traffic control, setting the flight paths and making sure everyone stays safe, then the data plane is like the actual airplanes carrying the passengers and cargo.
Exactly. A perfect analogy. And it highlights the key difference between these two planes. Now, let's wrap things up by talking about access control models. Your notes mentioned several different models: MS, RBAC, DC, and rule-based access control. Can we break those down quickly?
Yeah, they all sound pretty similar, to be honest.
Yeah.
What are the key differences and how do they relate to this overall idea of segmentation?
Sure. Let's start with mandatory access control, or MA. This is a very strict model, often used in high-security environments like the military or government agencies. It's all about classifying data based on its sensitivity and then granting access based on user clearances.
So you need a certain level of security clearance to access certain types of information.
Exactly, and the system enforces those rules very rigidly. Users typically can't override them. Now, role-based access control, or RBAC, is a bit more flexible. Here, access is granted based on the user's role within the organization.
So if you're in the marketing department, you get access to marketing resources.
Precisely. It's a way to streamline access management by grouping users with similar job functions and giving them access to the things they need to do their work.
It sounds very efficient.
It is. Now, discretionary access control, or DA, puts the control in the hands of the data owner. The owner of a file or resource gets to decide who has access to it.
So it's like having your own little kingdom where you get to set the rules.
That's a good way to think about it. This is the model that's typically used in personal computer operating systems, where you can set permissions for your own files. Finally, rule-based access control is kind of a catch-all term. It essentially means that access is granted or denied based on a set of predefined rules.
So it's not tied to specific user roles like RBAC, but rather to specific conditions that are defined by the administrator.
Exactly. Those rules could be based on the time of day, the user's location, the type of device they're using, all sorts of things. It gives you a lot of flexibility in defining very specific access control policies.
Okay, so we've covered a lot of ground today. We started with the basic idea of logical segmentation, dividing things up to improve security and manageability, and then we went deep into different network models, architectural approaches, security principles, and even access control models.
It's been a whirlwind tour of some pretty complex concepts, but hopefully we've managed to make it all a bit more digestible.
I think so too, and I think the key takeaway is that security is not just about technology. It's about thinking strategically about how you design and structure your systems from the ground up. It's about understanding the different models and approaches, and then choosing the ones that best fit your specific needs and risk tolerance. So thinking about all these different layers of security, these different models and principles, what do you think is the biggest challenge for organizations today, especially those that are rapidly growing and evolving?
That's a great question. I think the biggest hurdle is, well, just keeping up with the pace of change. Technology is evolving so rapidly, and the threat landscape is constantly shifting. It's a real challenge to stay ahead of the curve. You've got new cloud services popping up all the time, new devices connecting to the network, new vulnerabilities being discovered every day, and trying to implement a coherent, comprehensive security strategy across all of that is a moving target.
Yeah.
It requires a lot of flexibility, a lot of adaptability, and a willingness to constantly reevaluate your assumptions and your approach. You can't just set it and forget it. You need to be constantly learning, constantly adapting, and constantly improving.
Well, that's a sobering thought, but an important one. We're living in a complex world, and security is a never-ending journey, not a destination.
Absolutely. But it's a journey worth taking, because at the end of the day, it's about protecting the things that matter most: our data, our privacy, our businesses, our lives.
Well said. Thank you so much for joining me on this deep dive. It's been a fascinating and thought-provoking discussion. And to you, our listener, thank you for sticking with us. We hope you've gained some valuable insights into this critical aspect of security and system design.
It was a pleasure. And remember, stay vigilant, stay informed, and stay secure.